Just a couple of things about the 4-block. It is fantastic. What we used to find in the past is students either got 0 on a thinking problem or perfect on a thinking problem. There really wasn't a lot in between. They either looked right at it and said, I have no idea where to begin, or, oh yeah, I get this, and unless there was a small calculation error, they would get pretty much perfect on it. And so we would say, oh, just show me your thinking. You know, it doesn't matter if your answer, just show me your thinking. But we never gave them a method to do that. We never gave them a process to do that. And we didn't fully understand how difficult it was for them to do that until we got talking with our grade 7 and 8 colleagues in a middle years collaborative inquiry we did. And it was really awesome to do that, and we brought this up from our grade 7 and 8 colleagues into grade 9. And this is fantastic. And when I first do the 4-block, I spend a lot of time in groups. They got the large whiteboards on the first block. I say, just fill the first block in. What do we know? What do we need to find out? And what do I predict? This goes great. This goes fairly well. You'll be amazed at how they don't answer the question with the what I need to find out. Or they jump straight to the final answer and forget, oh, I need to find this out first before I find that out. So I really try and push that idea. Well, what do you need to find out before you can find that out? The prediction is what you really have to push hard. Students are still a little resistant, even though I feel as though I can create a really positive collaborative atmosphere. They're still resistant at making predictions, putting that number out there. I find a lot of students solve the whole thing, and then they take their final answer and go back and write it in the predictions column. Like, wow, 22.7 was your prediction as well. That's awesome. But you know, and I say, I want to just see a prediction. So if I don't see a lot of predictions when we do this first block together, I'll push it. I'll do a Dan Meyer. I'll say, okay, what answer is way too low? Give me a number. 10? 10 is too low? Okay, what's way too high? Reasonable, but way too high. 7, perfect. So everyone believes it's between 10 and 7? Yes. All right, I'm going to start calling out numbers. I'm going up by 5. So you put your hand up when you think we're there. 15, 20, 25, 30, and then all of a sudden you get hands. I'm like, okay, as a class, it looks like our prediction is this. The other reason I push the prediction is because I tell them, you've made your work really easy here. Your prediction was right, and you reflect on your prediction and talk about why it was right, or it was way off, and you talk about the misconception you had at the start. My prediction was way off, but the reason was because I forgot 0.8 was 80% and not 8%, or something along those lines. Like, it could be something as simple as that. So it works out really well that way to have students do that. And we feel in our department, if you can understand what you know, what you need to find out, and make an intelligent prediction with the why, you're at a level 1 already. That's short understanding the problem, what you need to do, and what a prediction is. And then you make your plan from there. So it really moves us from that whole idea of zeros into a full spectrum.